In this problem, we're asked to find the voltage V0, and we have a set of coupled inductors. So we're going to utilize our problem-solving strategy entitled Magnetic Coupled Inductors. And the first step in that strategy says assign mesh currents. So we're going to assign mesh current. So here's I1. Here's mesh current I2. And now we're going to apply KVL to write the mesh equations. And if a defined current enters a dot, it's going to produce a voltage positive at the other dot, and vice versa. So let's start with the mesh on the left in the upper left corner. So we'll have 4 I1 plus J2 times I1 minus I2. Just drop across this element. Then we'll have plus 24 at an angle of 10 is equal to 36 at an angle of 0. And if we simplify this, we'll have 4 plus J2 times I1 minus 2I2 is equal to 12.3646 minus J 4.1676. Okay, so here's one of our equations. Now let's go through the second mesh. So if we start here and go around, we'll have minus J3I2. Okay, now we'll have two terms for this inductor. One is just due to current I2 flowing through this coil, and that voltage polarity is going to be plus to minus, so we'll have J4I2. But now we also have current flowing through this other coil. It's also I2. They're coupled. So now if we look, I2 enters the undotted terminal. It's going to produce a voltage with that polarity. And notice it's the opposite polarity. So we're going to have a term minus J2I2. Okay, so this is a voltage term due to the current flowing in this other coupled coil. Okay, as we go around, we have 4I2 minus J4I2. Then we come around to the inductor on the bottom. We'll have this term, which is J4I2, and that term we'd have even if we didn't have any coupling. And now current I2 is defined as entering this dot, so it's going to produce a voltage plus to minus at the dot on the bottom. So we'll get a minus J2I2. Then if we come around, we'll get minus 24 to angle of 10, and then plus J2 times I2 minus I1, and all that's equal to 0. So if we go in and simplify, we get minus J2I1 plus 4 minus J1 I2 is equal to 24 at an angle of 10. So here's our second equation. So now we just need to solve those two equations, and we really only need I2. So if we look, I2 flows through those two elements. So solving using MATLAB, I2 turns out to be 5.8 at an angle of 32.86. And if we look back at our circuit diagram, V0 is 4 minus J4 times I2. Which is 32.79 at an angle of minus 12.14 degrees.